Hello and welcome to the last module. In this module, we will learn more about monitoring, scaling, and load balancing. I once read somewhere, simplicity scales and complexity fails. In the earlier sections, you have learned how applications can be hosted on Amazon EC2 instances. However, is your system architected to handle scaling from 100 requests to 1,000,000 or more requests? This does not mean we over-provision in advance. Rather, how do we scale on demand is a good question. Amazon CloudWatch, auto-scaling, and elastic load balancing, or ELB, form a triad of services that can assist with scaling. Amazon CloudWatch is a monitoring service for AWS cloud resources and the applications you run on AWS. Amazon CloudWatch supports a variety of metrics. In this example, Amazon CloudWatch is shown monitoring ELB latency and CPU utilization of Amazon EC2 instances. When an Amazon CloudWatch alarm is triggered, a corresponding auto-scaling policy is triggered to create a new instance. The instance is then added to the auto-scaling group. Remember to create at least 2 auto-scaling policies, one to scale out and the other to scale in. Finally, auto-scaling notifies the ELB that a new instance has been added to the group, after which the ELB starts to distribute load to the newly created instance. This way, all the 3 AWS services complement one another to efficiently scale an application. ELB helps distribute traffic across multiple instances or containers. Let us learn more about ELB. There are 2 types of ELB. The first is a classic load balancer that monitors the health of backend instances and distributes traffic to the instance with the least number of pending connections. An application load balancer, like a classic load balancer, also monitors the health of backend instances and distributes traffic to the instance with the least number of pending connections. However, an application load balancer is designed to handle traffic at the application layer of the OSI model. The application load balancer, or ALB, can distribute traffic to backend targets based on the path. For example, all traffic to example.com would go to the first target group. Traffic to example.com/API would go to the second target group, and traffic to example.com/mobile would be distributed to the third target group. Let us learn more about Amazon CloudWatch. Amazon CloudWatch metrics can be viewed on the management console or accessed using the AWS CLI. Let us familiarize ourselves with some Amazon CloudWatch terms. Standard metrics offered by Amazon CloudWatch are complementary. You can create custom metrics if the required metric is not a standard metric. Some examples of custom metrics are number of web page views, memory utilization on an Amazon EC2 instance, or JBoss utilization of an application. Amazon CloudWatch offers integration with many third-party tools such as Nagios, Splunk, and Datadog, to name a few. Amazon CloudWatch alarms can be used to notify administrators about an event such as an instance creation or a new job in an Amazon SQS queue. In addition to standard email, Amazon CloudWatch can integrate with Amazon SNS that supports HTTP and SMS, among other options. From our earlier discussion, we learned that Amazon CloudWatch enables auto-scaling to dynamically determine the right time to scale an auto-scaling group. Auto-scaling is a web service designed to launch or terminate Amazon EC2 instances automatically based on user-defined policies, schedules, and health checks. Setting up auto-scaling involves 3 steps. The first step is to create a launch configuration. You will notice the options specified here are the same you would have used to create a new instance. In other words, at this stage, you help autoscaling determine what kind of instance should it create. The next time a scaling requirement arises. An autoscaling group is a logical group of autoscaling instances. When an autoscaling group is created, we would have to specify the VPC and subnets autoscaling should use. We also specify the minimum and the maximum sizes of the group. Autoscaling will ensure that minimum number is maintained by creating new instances to maintain the minimum number if needed. Desired capacity is an optional configuration. It can be used to specify the optimum number of instances needed. If a desired capacity is specified, then the autoscaling group would start with the desired number of servers in the group. If a desired capacity is not specified, then the minimum size becomes the desired capacity. The maximum size refers to the limit of the number of servers in the group. Depending on the traffic directed to the application, Amazon EC2 instances can now scale between the minimum and maximum numbers. The final part of autoscaling is to define when should autoscaling scale. Autoscaling can scale based on time defined as a scheduled event or based on an Amazon CloudWatch metric that could be more dynamic. In this example, you see the scale-out operation first creates an instance before adding it to the group. Similarly, a scale-in operation first detaches the instance from the group before terminating it. In summary, Amazon CloudWatch, autoscaling, and ELB can be used to work together to ensure application availability. Now let's look at a demo to reinforce what we have covered. Let's see how ELB, autoscaling, and CloudWatch can work together to scale an application. On the Amazon EC2 console, we have created a web server which can be accessed using its public IP address. Let's now create an AMI which will be used a little later in an autoscaling group. After giving the AMI a name and a description, let's click on Create Image. AMI creation will take some time, and its progress can be verified by clicking on AMIs on the EC2 dashboard. Let's now create an application load balancer. We start by giving the load balancer a name. We can specify if the load balancer should be publicly accessible and what port should be open. The VPC and the public subnets for the ALB are defined next. In step 3, we select an HTTP security group to permit web server traffic. In step 4, we create a target group that will consist of Amazon EC2 instances from the autoscaling group. Targets will be later registered once the autoscaling group has been created. After reviewing the options, we click on Create. Let's verify if the AMI is ready. While the AMI is being created, let's proceed to the autoscaling configuration. We start by creating a launch configuration and then proceed to select the web server AMI. Let's click on Next, Configure Details, and give the launch configuration a name. We then enable detail monitoring, and since the web service will not be publicly exposed, we can choose the Do Not Assign a Public IP Address to Any Instance option. Let's click on Next and select the HTTP security group. And finally click Create Launch Configuration. We then proceed to create an autoscaling group. Let's define the group size as 2, followed by the VPC and the private subnets for the web servers. Under Advanced Details, let's enable the option to receive traffic from the ELB. We also enable ELB health check and detailed monitoring. In the Create Autoscaling Group section, let's create an autoscaling policy to scale between 2 and 6 instances. In the Increase Autoscaling Policy section, let's define the average CPU utilization to be greater than or equal to 60% and name the alarm as Scale-Out. We then specify the action to add 1 instance and the warm-up period as 60 seconds. We similarly create a scale-in alarm with the CPU utilization to be less than or equal to 20%. Let's call the alarm Scale-In. Let's choose the option to remove 1 instance if the condition is true. We then tag the autoscaling group and finally click on Create Autoscaling Group. Autoscaling should now start creating 2 instances, and it should take some time for it to be ready. You can check the availability of the 2 instances under Autoscaling Groups or Instances on the EC2 dashboard. Let's click on Target Groups and make sure the targets are healthy. After verifying the status, we can go to the load balancers and access the ALB by using its DNS name. We could compare the instance ID to make sure the ALB is pointing to the newly created instance. Let's add some load on the backend instance. This should take some time to reflect in CloudWatch as an alarm. You will notice the alarms transition from scale-in alarm to an OK state, and finally the scale-out alarm would be triggered. It could take some time for the scale-out alarm to be triggered. Once the scale-out alarm has been triggered, autoscaling should add another instance to the autoscaling group. Let's check the autoscaling group to verify if a new instance has been created. This concludes the autoscaling demo. We have now completed Module 5.